Hi there, and welcome to the revision part of this series where we get to check out what we've been talking about since the commencement of this series. Let's get what let's get into what we've been dealing with since the commencement. We're beginning with a formula sheet, okay? We're giving you a rundown of the important and basic formulas that you need to have up your sleeves whenever you're stepping into the examination hall. So these are not many, okay? Trust me, they're not many, but they are powerful. Once you have all these up your sleeves, trust me, no question should be anything but a walkover for you. So we have the first one, which is the formula that helps you convert from the mass into the mole, okay? To get the number of moles of a substance, you just simply divide the mass of that substance by its molar mass. That is formula number one. The second one is to get the mass of a substance, you just simply multiply the mole by its molar mass. Simple as A, B, and C. So let's move on to the next set. We have the number of moles which can be converted into the number of particles present. So to do that, you simply say the number of particles, whether they are molecules, atoms, ions, whatever it may be. The number of particles can be calculated if you know the number of moles, and it is equal to the number of moles multiplied by Avogadro's number. Avogadro's number is 6.02 times 10 raised to the power of 23. And then we have the number of moles, which can be calculated as well. If you're given the number of particles and you're asked to calculate the number of moles, you simply say the number of moles is given by the number of particles divided by Avogadro's number, which is 6.02 times 10 raised to the power of 23. Okay, and the third one we have is for gases at standard temperature and pressure, STP. Now, at standard temperature and pressure, the number of moles for any gas is given by the volume divided by 22.4. Now, from this formula, we can also find out how to get the volume. If we're given the number of moles of any gas and we're asked to look for the volume, we simply say volume is equal to the number of moles multiplied by 22.4. Remember, the volume is measured usually in dm cube. All right, so let's move on to the next one, concentration. I love this one. Concentration is measured in moles per dm cube, and it is also called molarity, okay? So M is equal to the number of moles divided by the volume. Now, always remember that the volume is measured in dm cube, not cm cube. Using cm cube will make you miss the essence of the calculation. And then we have dilution. Dilution is one of the favorites of mine. We have M1V1 is equal to N2V2. Now, each of these have what they stand for. M1 here stands for the initial concentration or the initial molarity. And then the second one stands for the initial volume. Initial volume. So M2 here stands for the final concentration or the final molarity. And then V2 stands for the final volume. Final volume. I trust you're getting the hang of every bit of what we're talking about in today's lesson. We have percentage yield. Percentage yield is simply how efficient a reaction is, and it talks about actual yield divided by the theoretical yield and everything multiplied by 100. Then we have percentage composition. We're going to solve questions where we apply each of these formulas to them. It is the part, okay? So the part, maybe an element or whatever it is, divided by the whole multiplied by 100. So for instance, let's say you have CO2 and you're asked to look for the percentage composition of carbon in CO2. You would simply say the relative atomic mass of carbon divided by the molar mass of the entire compound, which is CO2, everything multiplied by 100. That will give you the percentage composition of carbon in CO2. That's how that formula can be used. And then here are some exercise questions that we're going to be doing together, but I want you to try out your hands on them before the next video where I post them. So we have the first question, the second, and the third on the screen right now. We have the fourth, the fifth, and the sixth. You can pause the video, check them out, and do justice to them. I'd like to see your answers to these questions in the comment section, and I look forward to replying every single one of your comments. Then we have 7, 8, 9, and then finally we have number 10. 10 solid questions for you to deal with. It's been an absolute jolly ride for me being with you from the beginning of this series, the mole concept, up until this point where we have talked about the exercise questions. I trust you enjoyed every bit of it. I did, and I look forward to seeing you in many, many more of my series to come. In the next video, I'll be doing the solutions to this, and I look forward to seeing you there. With that being said, I will see you in the next video.